Alright, here we go. We are finding all the roots of a polynomial function that is to the fifth power. Find all roots. And we've got to use a tremendous amount of knowledge and tools in order to be able to solve this problem. Okay? Find all the roots. The first thing we need to do is list out all the possible zeros. What are the possible zeros for this polynomial? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Is that all of them? How do we get that? Anybody? Plus or minus what? P over Q. That number, all the factors of that number, over all the factors of that number. Okay, so there's all of our possible zeros. So we use the calculate function on our calculator and we try each one of those till we have a one that works. Right? We try positive one. Did positive one work?
Yes.
Oh, so right off the bat, the first one that we tried worked. So we do synthetic division and we plug in a positive 1. Okay, hold on. This is to bring it down a notch. We're at x to the 5th and we're going to try to bring it down to x to the 4th. Y'all are saying that 1 works. Right? So 1 drops down, I get 1 right here, that gives me 0, that gives me 0 here, -7, 4, 1, add that up and get 20, 20, and 0. So positive 1 does work. And our answer, we know that 1 is a 0. We have one real root at least, and it's positive 1. If we start off with x to the 5th, what does this have to be? X to the 4th, x cubed, x squared, x, and no x. Make sure you go back and put your positives in there. The remainder of 0 means we've now down to this level. Alright, so then we start trying zeros again. We go back to our list. We know that 1 worked, we try -1. Does -1 work? No. So we try 2. Does 2 work? No. Does -2 work? -2 works. So we do synthetic division again. See how I'm lined all this up? It's nice and easy. We do -2. Y'all are using the calculate function to decide whether or not the zeros work to save you a little bit of time. Okay? -2. 1 drops down. I get -2, -2, 4, -3, 6, 10, -20, and 0. Okay? So if we started off with x to the 4th, this is good that we got 0. If we started off with x to the 4th, what does this have to be? X cubed minus 2x squared minus 3x plus 10. So now we're at a cubic function, right? What can we use on our calculator?
Mode 54.
Mode 54. There's A, there's B, there's C, there's D, right? And I'm sorry, -2 is a root or a 0. The calculator is going to give us our 3 other answers. In this particular problem, what are they?
-2.
-2.
2 plus I.
2 plus I. And if 2 plus I is a root, what has to be a root?
2 minus I.
2 minus I. Why? Because they're conjugates. And we have a theorem that says every complex root and its conjugate have to both be in there. If 2 plus I is in there, then 2 minus I has to be in there as well. Alright, so we need to add this to our list. -2 is right there, and 2 plus I and 2 minus I. So how many roots did we end up with?
5.
5 roots. What was our degree to begin with? 5. And that's an example of what theorem? A fundamental theorem of algebra. Okay, it says that if it has a degree of 5, then you have 5 roots. Questions? Raise your hand. Adam.
Why is 2 -2s up there? See, it says x equals 1, -2, -2.
It repeated. It repeated. If I said x plus 5 times x plus 5 is equal to 0, then how many roots do you have? Well, you get -5 twice. You can put it once, or you can put it twice. I would not mark it wrong if you only put it one time. Does that answer your question?
Yeah.
I just didn't want you to leave it out because the calculator gave it to you. Go ahead and put it in there. Okay? Good question. Kiki.
Okay, so whenever the first step whenever you plug in the problem with alpha and x to the fifth and all that.
Oh, I'm sorry. X to the fifth. You're here.
Yeah.
You plug in this root and you take it down a notch. All right, I'm with you.
So you know that it can work whenever you press equal. After you press calculate 1 and you press equal and you get 0.
That's right. Because 0 equals 0. If you get any number other than 0, then it's not a root. Okay? Like when you're hitting calculate and you plug in 1 and it works, yay, right? Because you don't have to try all of these. Right? What if the roots were 5, 10, and 20? That means you would have to try 6 different roots before you got there. So when you try 1 and it works, yay, right? Throw a party in your head, right? A little happy party that 1 worked on the first try. Okay? Questions? Any questions? This is as hard as it gets with this type of problem. I'm not going to give you to the 6th or to the 7th or anything like that. I'll probably give it to the 5th. Yes, ma'am?
So if it asks like how many roots does it have, would I put 4 or 5?
You would say either answer is correct. It has 4 roots if you don't repeat, and it actually has 5 roots, -2 repeats. What does that look like? See who's paying attention. What does that look like on the graph?
It bounces.
That's exactly right. It bounces at -2. Okay? See, that's what we remembered from 2 weeks ago. All right, last thing. Dustin and I were talking. If your calculator's in complex mode and you type in this function and you type in 2 plus I and hit equals, do you get 0? Says math error. That's a bummer. I was hoping that it would be a way of checking to see if that would work. Maybe we can figure out a way around that. But if you type in 1 or -2, does it work? Of course, because there's zeros. Okay? Questions? Yes, ma'am.
How is this different from yesterday?
Because yesterday we didn't get any complex numbers. Okay? Good question. All right.